All right, we are live. Hey, thanks everyone for joining. We'll just give maybe 30 seconds or a minute to let folks trickle in via LinkedIn and YouTube, and we will get rolling. And hopefully the trash truck that just pulled up near my house is not creating too much background noise, because perfect timing, of course. Oh, good. I'm told that you cannot hear it. That's good. All right. Well, we can get rolling here a bit. Thanks, everyone, for joining in to our first virtual meetup around ToolHive, which is an open source project from StackLock to make MCP servers easy and secure. Start off with some introductions. First off, who are we? So StackLock is building simple and secure AI tools. One of the things we're working on a lot is connecting AI agents to data and systems so that you, as a developer or DevOps professional or whatever your role may be, can get the important work done without the added friction that sometimes comes along with these tools. So I am Dan Barr. I am a technical marketing engineer here at StackLock, and I'm joined by
Chris, sorry, just getting off mute there. Chris Burns, Site Reliability Engineer, or SRE for short, for StackLock, and I work on ToolHive and the operator.
And Chris will be taking us through the hands-on portion of the ToolHive Kubernetes Operator demo, which is great because he has been one of the most involved engineers here building the operator. So we get that firsthand knowledge from Chris. So I'll start off talking about some of the friction points around MCP, and I'm going to make a bit of an assumption that if you're here, you're at least somewhat familiar with MCP, but the 30-second version of MCP is it's the Model Context Protocol, right? It's an open, standardized protocol that was originally released by Anthropic, and it basically connects AI workflows, AI agents to external systems, data, APIs, what have you. And so if you think about like a large language model is basically a brain in a box, right? It can't do anything. It can just think. And it has knowledge that it was trained on, but nothing beyond that. AI agents and applications give it a pair of hands that it can work with things outside of its box. And then MCP puts tools into the agent's hands, right? So it allows the agent to interact with SaaS services, databases, shell commands, edit files, those sorts of things. So that's really what MCP is doing. But we've seen some friction points around MCP. The first one is discovery and trust. So MCP as a protocol is only about 6 months old. It was released in November of 2024 is when the first spec came out from Anthropic. The popularity exploded, right? There's already thousands of MCP servers out there in the community, but the quality is really uneven, and finding the right MCP for the right job can be really difficult. There's a lot of like community maintained awesome lists, so-called awesome lists out there, a handful of large but unofficial directories. And there's not a lot of like vetting of this point of origin and the trustworthiness of these MCP servers going on. There's some efforts around the community on this, but obviously this is one of the things we wanted to solve with ToolHive. Another one is inconsistent installation. So along with the spec, Anthropic also released SDKs for all the major languages, Python, JavaScript, Node.js, Go. I think there's a Rust SDK too. And so what ended up happening is as people started building MCPs, they got built in all these different languages. So getting MCP servers up and running might mean that you have to install Python and UV and Node.js and NPM and Go and Rust just to get these things up and running. So that can be really frustrating, especially if you don't normally use those tools. And finally, security and isolation have to be a huge concern. MCP servers are executable code that you are running on your machine. So you need to be sure that it's doing the things you think it's doing. There are MCP-specific attack vectors, things like tool poisoning, and the traditional security scanners really just haven't caught up yet. So isolation is a concern, but also a lot of MCP servers to interact with the services they're interacting with need secrets. They might need an API key to talk to your SaaS service or username and password for your database to connect to. And typically the approach has been you need to put those credentials into a plain text configuration file in your client. So obviously that is a big concern. So enter ToolHive, and those are the things we are solving with ToolHive. First around discovery and trust, ToolHive includes a curated MCP registry. This is a registry we have put together. We've published recently our inclusion criteria and the kinds of things we look for in MCP servers before we'll include them. And we're really going to be ramping up our efforts to expand the size of that built-in registry. Or you can build your own and actually refer ToolHive to your own copy of a registry. And also provenance verification is something we landed pretty recently. So you can verify that that image hasn't been tampered with since it was published, that it came from where it's supposed to have come from. Around installation, well, we've solved, I mean, the industry solved the multiple runtime, multiple languages problem ages ago. It's called containers, right? And so we really believe that the right place for an MCP server to run is inside a container. So that is exactly what ToolHive does. It runs all of the MCP servers that you manage with ToolHive run inside containers. And we can even do on-the-fly builds out of any Python, JavaScript, or Go-based MCP server. So you don't need to have those tools installed locally. We'll just package it up and run it in a container for you. And finally, security and isolation. Obviously, containerization brings with it isolation, right? Now that MCP server is running in its own little bubble, it can't access things on your file system unless you explicitly mount them in. ToolHive includes encrypted secrets management. So it's going to encrypt those secrets and securely pass those into the containerized MCP server. And permissions policies, so we can control file system access. And also, we've got coming out really soon egress network filtering for MCP servers, so you can control what they can actually connect to in the outside world. So, before ToolHive, this is kind of what it looked like, right? You have your MCP client. It might be VS Code with Copilot. It could be Cursor, Windsurf, a bunch of different clients that all support MCP. And they're just executing MCP servers locally using UVX for Python or Go or NPX for JavaScript-based MCP servers. With ToolHive, we have the ToolHive CLI. We have two methods currently that you can use ToolHive. One is the CLI, and this is really for an individual, local installation. So the ToolHive CLI interacts with Docker or Podman and spins up the MCP server containers and then exposes them with an SSE proxy process that your client will then connect to. That means that the client only needs to have a URL, right? All of the secrets handling and injecting of the secrets is done by ToolHive securely, and your client just needs a simple URL to connect through to that MCP server, and this can all happen locally on your machine. But obviously today we are here to talk about Kubernetes. So we also have a Kubernetes operator for ToolHive. And the way this works at a high level, and Chris is going to go into a lot more detail around this, but at a high level, the way this works is the ToolHive operator is running inside your Kubernetes cluster. When you create a new custom MCP server resource, it is going to create a pod and an associated service for the SSE proxy. It's kind of a proxy and runner all in one for the MCP server. And then the proxy actually creates a separate pod completely isolated from the rest of the cluster containing the actual MCP server that you specified. And then once that's all created, right, we can wire up that communication path from your MCP client through your existing Kubernetes ingress mechanisms that wires up that connection all the way through to the MCP server. Now, centralized deployment is obviously one of the reasons we were looking at Kubernetes deployments here. As you go from an individual developer to whole teams that need access to MCP servers, there's some challenges that come into play. The first is obviously secure communication. The actual MCP spec only really includes standard input-output for local execution of MCP servers and unencrypted HTTP streaming HTTP transports. So it's really up to you to secure those communications. So our approach here is just, well, let's not reinvent the wheel, use existing technologies, use your existing secure transport using whatever you're using as Kubernetes ingress, and take advantage of that. So, ToolHive is not trying to reinvent that wheel, right? We expose the service and let you wire that up through your secure ingress. The other big piece that is still very much developing in the MCP world is authentication and authorization, right? Now, if you start hosting MCP servers centrally for a team, for a whole department, we need that authorization so that the right people are getting access to the right tools, and you're not just opening those things up widely. So our approach, while the kind of official MCP authorization spec is still in development, it really has been unevenly adopted. Our approach is an OAuth, OIDC-based authentication framework, but just as a reality check, right? Client support is still a challenge. Most clients still do not support an OAuth authentication flow for MCP servers, and so we're really actively working on some solutions around that, right? To either proxy that through, or to bring, in the Kubernetes context, we can do things like service-to-service authentication. So if you're running, say, an MCP client or an agent in another Kubernetes pod in your Kubernetes cluster, right, you can do service-to-service, so IDC-based authentication to the MCP servers. But still very much an evolving space here. But with that, I'll stop talking and want to hand it over to Chris here so we can actually get hands-on. Again, if you're following along, if you have, a Kubernetes cluster, if you have Docker and Kind installed locally, you can follow along with what Chris is going to do here. In the email, we sent along the links to the documents that Chris will be looking at, and I'll post them in the chat too to make sure you have those. But I'll hand it over to Chris at this point.
Cool. So I'm just going to wait for my screen to pop up on the stream. There we go. Cool. Awesome. All right. I was going to go through some basic Kubernetes architectural questions, but I think Dan pretty much nailed all the details there, so I probably don't need to add much more there, which is good. So first question people may ask is, what is the reason that we chose an operator? Kubernetes operators themselves can be quite complex. However, they do have benefits to them. If you write them in a nice way, they do hide complexity behind the simple interfaces. And given the fact that MCP is a bit of a Wild West at the moment, and it still probably will be for the near future, we want to abstract as much complexity and security away as possible, giving users a more pleasant experience, shall we say. This somewhat prevents the situation of manifest hell as well, where you have to apply a bunch of YAML manifests to get a single MCP server to work. And I'm not even going to get started on the additional manifest that you need for increased security and networking and that kind of stuff. So that's the reason why we thought of an operator, was because at some point people are going to want to run these inside of Kubernetes, and to avoid issues with people having to learn Kubernetes at the same time, we thought creating an operator would be a good idea for this, given that we're also Kubernetes people here at Stacklock. So that's I guess the history or the reasons why we chose to do the operator. Starting from, I guess, the beginning, for this demo, I will be using some simple things that you can download locally. I'll be using Kind, which stands for Kubernetes and Docker, and it's just a local way of running Kubernetes on your local computer using Docker. You will also need Docker as well, and optional, although we're not going to be using it for this demo. There's also Task as well, which just automates things a bit more for you. But for this demo, I will be doing things manually. I won't actually be using the TLDR approaches, because I want to kind of go into the steps of how we actually do this. It's not that long, it's quite simple, but as many steps as there are, I want to do them manually, just so you kind of see what's going on. So let's start. So we have guides here, and now we put under the docs /kind, and we'll be following 4 pages, namely, yeah, this is the start. So what we want to do is we want to create a client cluster, and we're going to specifically call it ToolHive. Just, I don't want it to conflict with any other clusters that I've got locally. So this will just create the single node cluster, which is just a control plane node for now, just because it's easiest. And given the fact that I don't want it to conflict with any of my other kubeconfig files, I'm just gonna paste this command here to output the kubeconfig for that cluster into a kconfig.yaml file. If you are following this yourselves now or in the future, do not worry about this file getting checked in, because it's in our get ignore, so it simply won't get checked in. And that's it. That's the kind cluster being set up. The next step now is to move over to the deploying of the ToolHive operator, and I've got that already open here in a tab. And again, we're going to skip past the TLDR version, which is just run task, and it does it for you. But we want to do this the good old hard way. So it's just 2 commands. So in this case, you want to install CRDs first, because there is a MCP server custom resource that we've created specifically, which I'll show you in a minute, for the operator to provision an MCP server. So before we actually apply those manifests for the MCP server, we want to apply the CRDs for them. Notice I'm adding the kubeconfig kconfig.yaml here, just to be sure that I'm applying it to my client cluster, because if you've got a bunch of clusters running locally, all kinds of things can happen if you don't specify kubeconfig or context. Okay, cool. So that's now the operator CRDs installed, and I'm just going to scoot back over to the README and get this command. And all this does is similar to the command above. We're using Helm to create a release called ToolHive Operator, and we're providing the chart for the operator, and we're providing the namespace that we want it to be installed inside. And given the fact that we haven't got that namespace existing at the moment, we're just going to add a little dash create namespace here, just so it Helm create it for us automatically, and then the kubeconfig file. So that will now go and install the operator, and there we go. The operator is now installed. Now, if I go to my trusty Kubernetes interactive client called K8s, and provide it the kconfig file, and I go to the kube ToolHive namespace, and we shall see the operator starting. It'll be version 0.039. It's in active development, so that version will get bumped up quite a bit. But there we go. That's the operator installed in our client cluster. Now, that's cool. It's quite easy. However, the thing that you're here to see is actually how you deploy an MCP server. And that is, again, quite simple. It's just a single apply of a manifest. If you're using GitOps, you would apply this manifest in your Git state, and then you'd have an agent such as Flux or Argo to apply that automatically for you. But in this case, we're just going to copy this command. Just going to exit out of there. I'm going to provide it with the kubeconfig file. It's going to make me type it out. And just for you to if you're wondering where this file is, this is actually in the repository, and I'll walk through that in a second. But it's just an MKP server, which is just a Kubernetes MCP server that we've built, and we're using it for this demo. So if I apply that, it's now being created. Now, if I go into Kubernetes again using K8s, we've applied it inside of the ToolHive namespace, and as the descriptions that Dan provided earlier on, you'll start to see those manifests now. So the ToolHive operator has detected that there is a MCP server custom resource, which is that one there, which is just what I've just applied. And what happens is the ToolHive operator will create the proxy runner deployment, which is this thing here. And then that runner itself will then create the necessary resources for this MCP server, depending on whether it's SDIO or SSE, which in this case, it creates a stateful set for the MCP server, and then a headless service as well. So now those are running. you probably want to know how you can communicate with them. Now, we do have a couple of docs on this. You have the ingress documents, which allows you to install an ingress controller. I'm not going to do that for now, just because it's got a lot more steps in there manually. So we're just going to go with the port forward instead, because that's quite simple to do. A little caveat that I will say, the ingress documentation using task, that's all automated for you. So it literally is just one command for you to bring this entire stack up with an ingress controller. But because we want to do things manually for now, just to kind of show you the steps, I won't go into that because there's quite a few steps that you have to do manually on that one. So we have a list of, we have our MCP server that we know exists inside of the cluster. Now what we want to do is we want to actually port forward to the port forward from the pod to our local machine. So if I just get this command and I cancel out of here, before I do that, I'm just going to do a service. The one that we want to port forward to will be the proxy service, because that's the service that handles all communications to the MCP server itself. So just to make a note of this, it'll be MCP/MKP/proxy, not forward slash, sorry, dash. So if I, that, so let me just copy and paste that properly. And then there, and then kconfig, and I want to change this to be MKP, not fetch. So if I do that, so now it's port forwarding. So now localhost 8080 should be exposed, or you should have access to that MCP server. So now if I go over to my trusty cursor client, which is here, I've already got this MCP server set up. What I mean by that is, if you use the ToolHive CLI to run a container locally without Kubernetes, this will actually get auto-populated. But given that we're in Kubernetes, I'd like to just add this configuration manually. But in this case, it's just the name of the server, the URL, which in this case is an SSE URL, and it's just port 8080/SSE. And if I click refresh here, you should see that there's two tools, get resource and get and list resources. Now, if I open up my chat using the Command and L tab, or the Command and L button on my Mac, and I ask it using the MKP MCP server, bit of a mouthful, can you describe, well, can you list all pods running in the ToolHive namespace or ToolHive system namespace? And it will generate a request for us. And in this specific case, it will talk only to the ToolHive system namespace, because that's what the permissions that I've given it are. I'll talk a bit more about the permissions kind of things in the multi-namespace deployment a bit later in the roadmap. But for now, given the fact that it's an MCP server that provides Kubernetes access in that one namespace, that's all we can find. So if I ask it, to give me pods based in another namespace, it won't have the permissions to do that, which is expected at the moment. And there we go. So it's given us a list of the pods that exist in this namespace. Now, I don't want you to focus too much on the capability of this MCP server, because it varies on the server. The thing I want you to focus more on is how easy it was to actually deploy an MCP server into the Kubernetes cluster. This, speaking earlier on about the manifest itself, this is the custom resource for the MCP server. It's got a couple of fields in here. These are changing as time goes by, because we're getting feedback from people saying, this is a bit, this is a bit more involved. Can you, can you simplify this down a little bit? So, but the general gist of it is, you have an MCP server image that you want to deploy. You have a transport type, so whether you want it to be SSE or SDIO. You have a port that you want it to be running on. You have permissions profiles as well, which is another roadmap issue that we've got to kind of really mature out. And you've got the pod template spec as well. So even if you really wanted to modify the actual pod template of the MCP server, we provide that capability. And then you have the standard resources stuff as well. And that's pretty much it. I mean, it really is that easy. We've got a couple of manifests here. We've got a fetch one, which allows us to, by default, we actually when we create these stateful sets for the MCP servers, we actually lock them down quite a lot. So we make sure that you can't run as root. We make sure you run as a non-root user. We don't allow privilege escalation. We really do lock it down by default. So the security that I mentioned earlier on is actually the reason why we really wanted to do the operators, because we're able to abstract all that below. But in this case, we've actually had to tell it that you can run as root, because the fetch image actually isn't, how can I say, it's not built in a way that allows you to run it as non-root. So we've actually had to say you can run as root in this case, which isn't good, but that's just the nature of MCP at the moment. There will be MCP servers that just work that way, unfortunately. But the one that we built ourselves actually do have all these settings turned on, so it's quite locked down. And yeah, like I said, there's a whole examples folder here in the ToolHive repo under examples, operator and MCP servers. Go and have a play around. It really is as simple as what I've just described. And if you want it to be even more simple, then you can just go straight to the task client with ToolHive Operator, and it will install the client cluster, it'll install Ingress, and it will also install the ToolHive Operator ready for you to start applying MCP servers. And that's pretty much it. I mean, I don't think there's anything I've missed. And by the way, the reason why there's an assumption that we've built around containers is, as we know, MCP is the Wild West. The reason why we want to use containers is because it's nice to have it grounded in kind of a mattress of familiarity. Containers have been around for a decade now. People are starting to really get comfortable with how they run Kubernetes and how they monitor them. So it just kind of made sense to run MCPs in Docker containers, because, like I said, it's a well-known domain at this point, and it's very likely that enterprise will have ecosystems that allow them to monitor these containers. I think that's it.
Yeah, I'm not seeing any questions that have come up. Actually, could you, back in the examples, could you maybe show an example that uses secrets and talk maybe a little bit about how we can inject secrets in?
Yeah, sure. So the GitHub one is a bit more sensitive in the sense that you have to give it an access token. And yeah, that's quite easy. That's just a matter of just adding the secrets that you want to access. There are outstanding work that I'd like to do in terms of the operator and ToolHive in general, which is to lock this down a bit more so that you don't provide them as environment variables. I know it's quite common for people to provide secrets as environment variable, but anyone who gets access to the shell or is able to run a command such as env just prints out your entire env stack, which means that all of your variables are just exposed. I much prefer mounting secrets as volumes, so that's something that we want to do in future. But for now, what this capability will do here is it will get the secret that you've specified, and it will just map that secret as a value in your environment variable, and then that container then will have, or the MCP server container will have this environment variable with your access token. And then you've got the standard environment variables as well, then, which you're able to provide at runtime.
Yeah. So again, just not trying to reinvent the wheel here with things like secrets handling, right? Using standard Kubernetes secrets and just referencing them. So if folks have other secrets providers wired up into their Kubernetes cluster, it should just work, right?
Yeah.
As long as they're exposed as Kubernetes secrets objects, right? Yeah.
Yeah, exactly. As long as they exist, it should just be a matter of that. And who's to say in future that people will say, "Oh, I love Kubernetes secrets for all of our due to policy, organizational policy. We have all of our secrets in Vault or Secrets Manager." These are again things that if we start to see real demand for them, it's just a matter of us adding that in. But now native Kubernetes secrets are supported.
Awesome. Well, just checking. I haven't seen any questions come up, so we can probably move on to talking a bit about what's coming up for ToolHive, right?
Yeah. So it's as people could imagine, it's quite a busy space. There's a lot of people, all different kinds of backgrounds, from security, from engineering, from dev, from just researching. There's a lot of people in this space, and the security folks, as always, were always the boring ones in the corner saying, "Has anyone thought about this? Has anyone thought about that?" But we've got kind of a good roadmap of what we think is something that we should be focusing on for the Kubernetes side of things. I spoke about it just a hint earlier on, but I really like to get the multi-namespace deployments down in Kubernetes so that you don't have to deploy your MCP servers in the the ToolHive system namespace, because at some point someone's going to want to put that in a different namespace. If you want to deploy a Postgres MCP server, it's going to be in a in a namespace where that database may be existing if it's in Kubernetes. So multi-namespace deployments are a big thing. I've actually got the PR up as a draft already, and it's just been finalized. So hopefully that'll go in over the next couple of working days, and it'll actually be quite secure as well. So it allows your ToolHive deployment or operator deployment to only have permissions that you want it to have in certain namespaces, as opposed to giving it cluster-wide access. We also have, as you've got on the screen there, you've got a bunch of telemetry stuff as well. So there's open telemetry, and you have a bunch of enterprise companies and folks that want to be able to monitor these things. So that's something that we're looking at the moment. So you can really get into details of analyzing your traffic going to and from to your MCP servers. And there's a bunch of security enhancements as well. So outbound network profiles. So making sure that if your MCP server is only supposed to be talking to a specific domain, make sure that it only has access to talk to that specific domain. And there's a bunch of stuff you can do layer 4 to layer 7 on making sure that you allow it access to only certain things, and that's work that's currently being done as well.
Great. So we did get a few questions started coming in now. First is Ivan, who asks, I'm relatively new to MCP. Why would you want to deploy an MCP server into Kubernetes? What problem is that solving?
Yeah, so locally, and this is where there's kind of two aspects to ToolHive at the moment. You've got the ToolHive Docker experience, which is great for local devs just wanted to run containers or just wanted to run MCP servers locally. But as an enterprise, they just simply won't allow developers to just run things locally, especially if that MCP server has privileged access to databases or whatever integration it has. So that's typically where enterprise will want it in a place that they already have a mature ecosystem, and Kubernetes is one of the more mature ecosystems. So when you're deploying these MCP servers at scale, this is where you have entire swaths of developers talking to MCP servers. You'll want that in a place that actually provides that scaling, and you have, like I said, the entire ecosystem of Kubernetes that is known now for quite a while. So you can always leverage those things around the edges of MCP itself.
Yeah, it really does become a scale and centralization problem once you go beyond, one or two individual developers trying to make sure that all their MCP environments are configured the same and doing the same things becomes pretty challenging. So getting that all centralized into one place, into your existing Kubernetes workflows and secure ingress and all that is really the problem we're trying to solve there. But yeah, as Chris mentioned, individual developer, right? We've got the ToolHive CLI, it just interacts with Docker or Podman locally. It's great for that individual use case. But yeah, as we go into team and enterprise environments, that centralization becomes really critical, and it'll only become a better and stronger story as things like authorization frameworks and client support for authentication and authorization really starts to develop, which we think will start happening pretty soon here. So. And we had another question here. Does the operator support multiple replicas for each MCP server? Does it create a replica set for each one?
Love that question. So that's actually something I was talking to a fellow colleague of mine earlier on about this. We're really interested actually in seeing how these scale, because if you think of the SDIO world where you're attaching to pods, things start to get really interesting there. But yes, it does support that because you can scale up to however many I think you want. However, The jury's still out. The jury's still out on whether the actual communication protocol itself supports that scaling. And this is where it gets quite interesting, because in Kubernetes you can scale, to hundreds of pods, thousands of pods even. But can the actual protocol itself support that happening? Because it's very, very interesting as a capability, but does it scale? This is where the evolution of the protocol itself will get pretty interesting over the next couple of years as people really want to start operating these at scale.
Yeah, I recall some of those internal discussions where I mean, there was really an assumption in the MCP spec of really a one-to-one relationship between client and server. And so, yeah, scaling that out and while keeping track of which client was talking to which instance of the MCP server. And so you're not crossing the streams and crossing replies. Yeah, it does start to get really interesting, but that's definitely things we're working on with the Kubernetes operator, and also probably needs maybe a little bit of a community evolution in the protocol itself to really support those use cases. So, like I said, it's only a 6-month-old protocol, right? We know how long, especially open and community protocols can start to take, to develop. But there's so much interest and activity around MCP that I think we'll start seeing those things happen for sure.
Yeah, for sure. And if we can help speed up, because security and reliability, scalability, all these kind of things almost get left to the end. It's like, oh, it works on my machine, great, yeah. And 6 months later, it still works on my machine, but it doesn't scale very well. If we can help, push these conversations left and earlier on in the timeline, then it just, it reduces the amount of negative attraction or the negative connotations that come with MCP, because a lot of people will start saying, well, these things don't do X or Y, and it really is just about coming together as a community and making sure that these discussions are being had, because like I said, it takes if you want to go further, go together, and
yeah, and that's the great thing about MCP being an open spec, and the fact that Anthropic did put it out in the community will help drive those kinds of use cases from the community. So, and speaking of community, obviously Chris talked about a few of the things we're working on right now with ToolHive. We've got a lot of things in the pipeline and a lot of ideas for it, and ToolHive is open source. Like, I don't know if we explicitly said that yet, but it is an open source project, completely free to use. So, your ideas, your contributions are very welcome. We have the GitHub repo and also our StackLock Discord channel that you can join and get involved. I haven't seen any other questions. If you have a question, definitely pop it into the chat. But otherwise, yeah, check out the repo. I think we can get the links posted again, maybe. But otherwise, yeah, thank you very much for joining, and we look forward to seeing you on Discord or seeing your issues and ideas on the GitHub repo. And thanks for joining us today.
Cheers.